Hi everyone, this is Miss Barber, and we are doing 5.4 Part 1, Square Root Property in Algebra 2. So for the warm-up, let's solve the following equation by factoring. So you might look here and you might want to draw your x where negative 64 is on the top, 0 is on the bottom, there is no b. Or you might say, oh, I noticed there's no b, so I can just take the square root of 64 and the square root of x squared, and I'm going to have x plus 8 and x minus 8 equaling 0. So then you set both parts equal to 0. And you say, okay, my two answers are positive 8 and negative 8. That was solving via factoring, okay? But we can also do there's also another way to solve these types of equations without factoring. And then that's called the square roots property. So you can use square roots to solve some quadratic equations. So if you have something like x squared equals a, as long as a is greater than 0, then you're going to have two solutions. We read this as the positive and the negative square root of that number. So like in my warm-up, I had positive and negative 8. We could write that as plus or minus 8. That's how you would see it written. So this is a way to solve equations just by using square roots. You have to get the squared term, so like your x squared or whatever it is. It might be x squared. It could also be x minus something squared. Whatever's being squared, get it by itself. You're going to take the square root of both sides, making sure to write the positive and negative answer, and then solve for x and simplify. So in example 1, again, I want to get x squared by itself. So first, I'm going to add 4 to both sides to get the x squared by itself. So I end up with x squared equals 16. I want to know what x is, so I'm going to take the square root of both sides. So now x is, this is where you got to remember, we're going to write plus or minus. Whenever you take the square root, you should be getting two answers. The positive and negative version of the square root of 16 is 4. So that's your answer, positive 4 and negative 4. Both of those, when you substitute them back in, will give you a correct answer. So for letter C, we're going to do the same thing, get our y squared by itself. This time to get y squared by itself, we have to divide by 3. The 3's will cancel on the left, so I'm left with y squared equals 8. I'm going to take the square root of both sides, just like I did above. I'm going to be left with y equals plus or minus. Now, the square root of 8 is not a perfect square. If you put it in your calculator, you're going to get a decimal answer. However, we do know back in chapter 1 how to simplify square roots. So if you think of the largest perfect square that goes into 8, well, the largest perfect square that goes into 8 is 4. So simplifying the square root of 8, I could write it as 4 times 2. And the square root of 4 is 2. So my final answer is going to be 2 root 2. I don't know what the square root of 2 is, so I can't simplify that any further. So that would be your answer. And then that's just the process we use for all of them. Let's try letter F because I see a fraction there and I know people tend to not like our fractions. So in letter F, to get x squared by itself, I'm going to get rid of this positive 5. It's positive, so to get rid of it, I can subtract, and I'll be left with x squared over 4 equals 18. Now, x is being divided by 4. The inverse of dividing by 4 is multiplying. So to get rid of that, I can multiply both sides by 4. So I'm left with x squared equals 72. Taking the square root of both sides, I'm going to get x equals plus or minus. Again, the 72 is not a perfect square. So I have to think of the largest perfect square that goes into 72. 36 goes into 72 2 times, so I can rewrite it as 36 times 2. The square root of 36 is 6, so I'm going to get plus or minus 6 root 2 as my final answer. So again, that's two answers. It's going to be the positive 6 root 2 and the negative 6 root 2. So in all of these, it was just an x squared term that was singular by itself. There was no parentheses or anything like that. But we can have them with parentheses as well. So the same rule applies. You need to get the grouping symbol by itself. So whatever is being squared needs to be by itself. In example 2a, my term x minus 3 is being squared. It's by itself. The squared term, the parentheses are by itself. So I can just take the square root of both sides. The square and the square root cancel on the left, and I'm left with x minus 3 equals plus or minus, again, don't forget that, the square root of 8. In the previous page, and letter C, we found the square root of 8 was 2 root 2. So I'm just going to go ahead and simplify it to 2 root 2. I still want to get x by itself, like in every equation. So now I can just keep simplifying. The inverse of minus 3 is plus 3, so I'm going to add 3 to both sides. So my final answer is going to be x equals 3 plus or minus 2 root 2. So 3 plus 2 root 2, that's a real number. It's a decimal, irrational number, but it is a number. That's one of the answers. And then 3 minus 2 root 2 is your second answer. We're getting 2 answers here, and then that's important to note. So let's try letter C. Letter C, my squared term, the x minus 4 in parentheses, it's being multiplied by 3, 1/3, sorry. So to get rid of the 1/3 or being multiplied by 1/3, if you multiply both sides by 3, 3 times 1/3 is 1. So then that will go away, and you'll be left with x minus 4 quantity squared equals 33. Now, my squared term's by itself, so I can take the square root of it. So I'm going to square root both sides, and I'll be left with x minus 4 equals plus or minus the square root of 33. The only two numbers that multiply to 33 are 3 and 11, so this can't be simplified any further. The last thing I need to do is just get x by itself. To get x by itself, I'm going to add 4. So x is equal to 4 plus or minus the square root of 33. And again, that is 2 separate answers. So letter D, you would do the same thing, except now we actually have 2 steps to get my x minus 3 term by itself. First thing I would do is add 8 to both sides. So I'm left with 7 times the quantity of x minus 3 squared equals 63. And then I can divide both sides by 7. So I'm left with x minus 3 equals 9. My x squared term's by itself, so I can take the square root. And I'm going to be left with x minus 3 equals plus or minus, what's the square root of 9? We know that. That's 3. So I can write that as 3. Finally, to solve, I'd have to add 3 to both sides. So I'm going to get x equals 3 plus or minus 3. Before in all of my examples, I had a square root at the end, so I couldn't simplify. But this time I can. I actually know what 3 plus 3 is. 3 plus 3 is 6, so that's going to be one of my zeros or my answers. 3 minus 3 is 0, so those are going to be your 2 answers. So again, you could simplify. Coming to my last 2 examples, I have, notice in both, I have a quadratic that's not been factored yet. However, it's written this way because these are actually perfect square trinomials, meaning when I factor my left side in both, I'm going to get the same factor for both. So I'm going to put 4 on top for my C, 4 on bottom for my B. My A is 1, so it's just going to be x. 2 numbers that multiply to 4 and add to 4 are going to be 2 and 2. So this is why it's called a perfect square trinomial, because my 2 factors are x plus 2 and x plus 2, which I can rewrite as x plus 2 quantity squared. Now this looks like just my problems above, so I can take the square root of both sides. I'm left with x plus 2 equals plus or minus 3. I can subtract 2 from both sides. So I'm left with x equals negative 2 plus or minus 3. Again, I actually can figure those two numbers out because I can simplify. -2 plus 3 is 1. -2 minus 3 is -5. So those will be your two answers. Letter G is going to be the same thing. You're going to factor the left and solve by taking the square root. So pause the video, try the ones I didn't do, and check your answer against the key. That's how we solve quadratics using the square